example briefly before we proceed. So example one, just one example. Example, find the moment of the force F about point A, right? Find the moment of the force F about point A in the diagram below. So how do we go about? Okay, let me draw the diagram. The diagram is like this. And then you have this. A lies this is the force. Then the distance A is at this point A. Then the distance from here to this very place, 6 meters. The value of this force F is 30 Newton, right? So have to find the moment of this force about point A. Alright, so let's do this moment of the force about point A solution. So what is the moment of a force about a point? We say moment of a force about a point is product of the force times the perpendicular distance, right? So now you'll be tempted most of the time to assume the perpendicular distance is this distance, 6 meter. But remember, what is perpendicular distance? It's the perpendicular distance from this force to the line of action of this very force. And sorry, an angle was given. So this angle is 60 degrees, right? It's 60 degrees. So an angle was given between here and here to be 60 degrees. Now you'll be tempted to feel maybe the perpendicular distance is equal to this distance. Remember, we said perpendicular distance is like the distance between the line of action of the force and the perpendicular from drawn from A to the line. So if you draw a line from here to here, but then this angle, this is the line of action of that force, this angle is not up to 90 degrees. That means this is not the perpendicular distance yet. So we'll have to erect the perpendicular distance like this, and then tag this with a 90-degree angle to signify that it's perpendicular. So if this is the case, that means here is also, if here is 90, here is also 90 degrees. And in that case, you end up with a right angle triangle whose hypotenuse is 6 meter with an angle 60 degrees. And then, sorry, the adjacent in this case is not 30 Newton, please, because you can't combine force in Newton and distance in meter in a triangle. They all have to have the same unit. So please don't make the mistake of feeling the adjacent to this is 30 degrees. And remember, the force is pointing this way. So we want to look for this perpendicular distance. Where is the perpendicular? I told you it's not this. This is the perpendicular distance D, right? So we want to look for D first. Let's find, because for us to get the moment A, we have our F to be equal to 30 Newton. But we don't know D yet. D is unknown. So for us to proceed, we have to look for D. Then how do we look for D? We recall that this is a right angle triangle, isn't it? If it is a right angle triangle, then we could apply our trigonometric ratios to it. So if you take the sine of angle 60, sine 60 would be equal to the opposite to this angle, which is D, divided by the hypotenuse, which is 6. So from here, you get your D to be equal to, if you make this subject formula, that will be 6 sine 60 degrees. So we end up with D to be 6 times 60. Then we substitute that, MA would be equal to F times D. Because we've known D, we just substitute that, 30 times 6 sine 60 degrees. And that would be equal to 1,500. 5.88, and the unit for moment is Newton meters. So our moment about point A is equal to 1.55.88, so 155.88 Newton meter, and that gives us the answer to this problem. um Next, we are going to look at more complex or more advanced examples on moments. Thank you for watching this section of week 1. I'll see you in the second section of week 1. Thank you.